better. Okay, so oh, that can't be ultra. Okay, so you guys were not able to see anything. Okay, so uh, I'm dealing with a lot of stuff. Wait a minute. Okay, so we also react to JRE's podcast. Okay, after this, because I am very interested in how Trump took. Yeah, this is him after winning, right? No, no, this is after him winning. Before him winning, he was so confident. That's for sure. Studio. Uh, there's some videos on my non-public channel, which not public channel. It was on my unlisted and it was listed. So I was able to- okay, so oh my god, why is you guys can't? Okay, wait, wait. Why is it on horizontal? Why is it capture like this? Wait, why did this move? Wait. Why is capture not horizontal? That's why I wanted a wide. Now it's better. GG. So much better. Now you can actually see what I'm studying. Okay, makes sense. So we are going through a lot of stuff very fast because I've studied everything and it will also help me revise. Okay, we will really fast jump on stuff. We will study about atmosphere and everything. It's gonna be very big revision. Okay, if I miss something, you guys can please put it in chat. Okay, I hope you can hear the desktop. music as well. Uh, yep, we can go ahead. So first we were studying about uh, Big Bang Theory. I actually restarted the stream. So, so one thing that you need to notice that when it comes to Immanuel Kant, uh, and this book is new for me. Immanuel Kant, okay, and I did take Baiju's stuff, but yeah, Immanuel Kant. Uh, i- one of the first theories was by Immanuel Kant that we need to know. Then Lapis took it. We got a Miller theory. Then Otto Schmidt came, and then came Otto Schmidt. They had the nebula theory with cigar. Nee, Chamberlain Moulton came with the cigar theory. Then Jeffrey came. Then they again took a nebula theory, which was by Lapis. So what we need to know is that the difference between modern and early theories, the modern usually talked as if sun was already present over there. Okay, but the modern theory started to dig much more around. They had a lot more expertise and stuff, and they started to find some peculiarities, and especially one of the biggest peculiarity, and which led to what we known as the Big Bang theory by Edwin Hubble in 1920. Okay, this is important. Okay, Big Bang theory was we don't know. They might ask. Unpredictable commission. Unpredictable Service Commission is the name of UPSC. So we'll go ahead. So we know with the Big Bang theory is that what Edwin Hubble noticed was that the distance between all the celestial objects in the solar system was in distance which were increasing to the sun. That means the distance between Mars and Venus, okay, it's increasing to the sun. That means Mars, Venus, Earth, uh, Earth, Mars, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, and Uranus and Neptune are not together in one circle. They are in their own different orbits, and each difference between each orbit was also increasing in matter, right? So hmm. And it was also found out the galaxies also move through the space. They also revolve in their own orbits. That was also a theory. It was like we know that the galaxies. This is sun. This is sun. Okay, sun. Earth is moving like this. Okay, the solar system moving is in the Milky Way. And Milky Way is also moving. So if Milky Way, the best example will be if Milky Way is moving, okay, so our solar system is. So he came up with the idea of Big Bang theory, and which we all know what is Big Bang theory is that the at some point of the time in galaxy, at least billions and billions of years ago, you can find 4.5 billion 4 billion years ago, 4.5 billion years ago, our Milky Way galaxy was a small tiny ball. Okay, uh, small tiny ball which then exploded after being contracted too much. No, wait, fuck. Oh, sorry, it's 13.7 billion years. My bad. There was a tiny ball, then expansion happened. Uh, Expansion happened, which is what we called as first stage is tiny ball. Let's not talk about solar system. What Edwin Hubble actually saw was that the distance between the galaxies are increasing. Tiny ball, the second stage is known as Big Bang, and the third stage is is it can be called, it was more like a settlement phase, right? It's like a settlement phase. So for something that you need to know is that the Big Bang theory does not talk about only Milky Way galaxy. It talks about all the galaxies. It talks about the generation of universe. Okay. Uh, so origin of universe as per Big Bang theory as per Edwin Hubble is that it was a small atom. Okay, and it was like a small atom, and then it got compressed so much that it exploded into a Big Bang. Okay, it is believed that that tiny ball had infinite temperature and yeah, density. It was like a it just as if we were all compressed, and it is a very wild concept. It makes you feel so much small in the universe. Is that we were this small, इतना सा, इतना सा भी नहीं हो सकता. Like we don't even know what was the volume. It was such a small volume that we were in more tiny volume, not we, the universe. I'm talking about. So universe was a small ball. That universe just suddenly exploded into a second stage called as Big Bang. And it is being found evidences of Big Bang because of the residual or the back radiations of the Big Bang itself. Because light moves, uh, light reaches places differently. Okay, in the distances of light. So we know that there are some background conditions which proves, not proves, which actually supports the Big Bang theory. And proves the universe, that small tiny ball exploded and became the background of the whole world, where all the galaxies started to come up. Okay, so that is one of the theories. Other theory is the theory of see, this is the, and we all still know that galaxies are going up, and we know that the galaxies will even collide in few not in few years, in like 2300 if I'm not wrong, not 2003, the 3000s, if I believe the galaxies will collide. Okay, I'm not, I there's a reason why I took zoology in BSc. Then whole concept of steady state suggested that this is not study. Okay, it just talked about the universe is always in a steady state. Okay. Oh yeah, see, the movement of object is relative to us is measured using Doppler shift, which helps us to identify objects coming towards us or receding us with help of its frequency. Why is it called blue shift? Blue has this shortest distance in the whole Wikipedia. I don't know. Something which is away from us will be red. Something which is coming towards us will be uh, blue. See, this is my cosmic microwave background. This is actually important. So, proofs of redshift. Here we talk about Doppler effect. Doppler effect is the Doppler effect is the understanding that is a concept that talks about how we perceive objects relative to light emitting objects. So that's how we talked about redshift, blue shift. Then comes Hubble's law. Which talks about distance away from us, right? This is a new pen, by the way, it's not working at all. So Big Bang 13.7 million years ago. Uh, Star formation 5 to 6 billion years ago. Sorry, BY. Uh, Formation of galaxies. I will also say it started in the same. I will say started just after Big Bang. So galaxies, we have three types: elliptical, spiral, and irregular. Same in spiral galaxy. So disk, bulge. Hello. See, this is the formation. Yeah. So the stars are localized lumps of gases. Then second stage. I was right. Okay, so I was right. Solar system was 4.5 py. Supernova happened, solar nebula happened, which means our sun was getting made. So a nebula is a cloud of hydrogen gas which starts spinning together, swirling together, and which is then called nebula. Some of so helium, hydrogen atoms, and everything together started to form uh, nebula, which, which made a clump of gas, which eventually gave birth to sun. Then afterwards, similarly in the nebula, which was continuously rotating, there were more clumps of matter, dust, and gases, which may have formed a different like different clumps of dust and gases which started spinning, forming a kind of like a core, which a core, a density of the matter, which started to have a gravitational force, and which we call such small circular objects in the universe as planetesimals. uh, the way it is planetesimals. So planetesimals, right? So that's what we call planetesimals. uh, Planetesimals then together start clumping because of different gravitational forces, and etc. reasons, and then they form a planet, a very large body. Planet. So this is how uh, major 8 planets of the solar system were formed. Other matter became asteroid belts. There were small stars also formed from that solar nebula. Then there was uh, a Kuiper belt, dwarf planets, dead planets, large moons, different moons started to form. This is because of the gravitational force, and different densities of planets started affecting how the system is, and obviously the gravitational pull of sun started to put all the planets into a more organized way, I will say. Basically, the sun became a manager because of the difference, because way the our planets were set after the formation of the planets. The planets were set in such a way that planets started to orbit the sun. There might have been collisions happening. The asteroid belts might uh, planets themselves, and they started colliding with the other planets, and so this might have been a residual of that. When then planets started to revolve. To remember the how the solar system is organized, you need to know the one diagram, that is my very educated mother, asteroid belt, just served us noodles and Kuiper belt. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Asteroid belt. Any planet comes before asteroid belt is called terrestrial or non-Jovian. Anything that comes after the asteroid belt is called Jovian planets. Why is it called Jovian planets? Is because of the asteroid belt, or it is usually because they are also called as gas giants. Terrestrial planets because they have terra, terrestrial, land. They have terrestrial planets because they have a proper mantle, they have proper crust. Uh, Whereas planets such as Jupiter, Saturn, Uranus, and Neptune, they are planets which are made up of a core and gas. We actually don't know, but we know it is majorly made of gases. This was yes. See, formation because they were close to planets. Parent star, they started to heat and condense and form solid particles. Jovian planets, because they were distant, they started to freeze. So the gas didn't have that much condensation, which would have led to formation of solid particles. then presence of gas and dust, because there were solar winds present near the parent star, so saw formation of actually an atmosphere that is removed. Removal of a lot of gases found on different terrestrial planets to clear this atmosphere, or not let unlike Earth, other planets were not that lucky enough. Especially Mercury, Venus, because they are so close to parent star. Most of the gases it had present either formed into the solid particle, which is now toxic metals uh, around its core, or it just escaped because of the solar winds. Whereas uh, whereas Earth is very lucky because the way it is in between Mars and Venus, that we have the uh, perfect temperature, and enough distance away from the sun that we were less not that affected as much as Venus, or not that less affected as much as Mars. That our atmosphere luckily had the perfect CHO, uh, CHNA, CHNS, I will say CHNS type atmosphere, where the life forming atmosphere was present and the other gases escaped. Mars was not that lucky. Similarly, it did not affect that much as Earth. It had a different effect. Some of the gases which might have been light supporting. We still don't know how much of that is true or not. But yeah, wait, okay, let me do something. Wait, my chat disconnected. Why did my chat disconnect? Oh, because it didn't pop out. So that's how we know. Then when it comes to the largest object of us in the sun, it's the parent star of our solar system. It was formed 5 to 6 billion years ago. That means formation of solar system happened 5 to 6 years ago. It contains 98% of total mass of the solar nebula. It appears to be active for past 4.6 billion years and can go for another 5 billion years. So, guys, after 5 billion years, we don't have sun. We start to Let's assume that it start to fuse into swallow up and usually swallow Earth. The sun has 5 layers. Something that you need to know is layers of sun. The sun has 5 layers. One is photosphere. (6K Celsius), photosphere, light sphere. Then you have sun has photosphere, chromosphere. Chromosphere is 4000 K Celsius, and you have sunspots, which you can see in photosphere. Then you have the outermost layer, corona, which generates 900 kms solar winds. If you want to know, if you want to remember solar winds, remember the movie Mission Mangal. You will see this how solar winds actually helped our satellite go into the right path. And we take a lot. We have a kind of like a meteorological winds. Like if someone lives on sun, they might have been using our satellite for what's the temperature is, what's the when is the solar winds gonna hit somewhere else. We predict that. Uh, if you want to talk about core has three parts, which is inner core. Core has three parts. There's this core, then comes convection zone and radiation zone. Three three forms of heat diffusal or heat transfer: conduction, convection, and radiation. Convection is the vibration of particles. Then you have Mercury. Uh, is the smallest planet closest to Sun. To remember Mercury, Mars, uh, then comes Venus is the sixth biggest. Venus, that's the fifth biggest. This is by the way, Earth reverses west to east. That's why sun settles at west. Makes sense, right? If west to east, west is always left. West to east, then the sun is here. Still west comes. Sun sets. For in Venus, sun settles in east because Venus goes like this. Mercury has where? Venus has one more. No. No, it does not have moon. Mercury doesn't have moon. Venus don't have moon. Earth has moon. Mars has two moons, Phobos and Deimos. Uh, then Jupiter has most amount of moons. 79. No, wait, I'm wrong. Oh, by the way, Venus. Acha, Saturn has 82. So we'll come to Earth directly. Earth has uh, Earth has lithosphere, atmosphere, biosphere, and hydrosphere. It's not talking about bio. It also has biosphere. It's product of three. Earth looks. Earth is 23 tours left. Right? Huh. It's like this, and Earth is flat on its slightly flat on its poles, and Earth probably looks like this. Orbit is elliptical in shape. Third, fourth, water, land, 23.5 degree tilt, 24 hours per rotation, and 365 point something days it takes. Shape is geoid. Lithosphere has crust, mm, outer, uh, crust mantle core, right? Hmm. Uh, crust, uh, crust, mantle, core. That's actually my outer core as well. We know lithosphere, like think about beaker, right? Okay, and I have a mixture of all the elements. Let's start heating this big. So the first elements to heavier metals and stuff, heavier metals and non-metals will first sink. Then the lighter ones will start to form gaseous. Okay, and there might be some fission here. That's what the whole concept is. The atmosphere, like we talked about, that solar winds sieved out at, gases from a lot of gases from all the planets atmosphere. So first was like a removal of primordial uh, atmosphere, then contribution from the Earth's terrestrial interior, मतलब like lithosphere's contribution were. Oh, and plants. Hmm. Life began to form 3800 MI. We know because then came 2000, 3000 million years ago. We had photosynthesis, and that 2000 MI, all oceans were filled. In One of the things that we learn in biology is how life forms came. So we know that some around 3,800 million years ago, uh, rainwater started, water started to condense, water vapors, which led to raining, right? Then raining led to cool down of the inner core. Uh, yeah, running into cool down of inner core, and then we started seeing formation of oceans, since water was getting collected in the depressions in the inner interior, Earth's interior, which is lithosphere. Uh, this depression oceans with a lot of elements from the lithosphere, and also whatever the water vapors were collecting and pouring down, to make this ocean with thunderstorms occurring, volcanoes incoming, led to contribution of many uh, elements such as carbon, hydrogen, oxygen, nitrogen, sulfur, zinc, iron, nickel, silicon, and a lot of stuff started to form primordial soap. So we know one of the first, first, we know that the first life forms started to happen in water, because water was the only topological existence in Earth about 3,000 million years ago. We know that blue green algae, which is the predecessor to chloroplasts in plants, right, which is required for photosynthesis. So blue green algae started to appear, and they started to appear in a lot of blue green algae is not an algae, it's a bacteria. If I'm not wrong, it is called as Echinobacter. Cyanobacteria, sorry. Cyanobacteria. And they started photosynthesis. This photosynthesis contribution contributed in sieving out the existing carbon dioxide into oxygen, which led to formation of aerobic bacteria and anaerobic bacteria. The bacteria that need oxygen and not need oxygen. This bacteria started to form proper cells, like small plant cells, animals, not cells, I will say, formation of Monera, and formation of Monera, protozoans, Monera protozoans, which led to advanced cells, advances leading to the existing evolutionary beings such as uh, arthrop in animal and plant kingdom, plant and fungi. These three started to come up. So that's how it works. That's how everything started. So the eons. Okay. So what was I talking about? I'm babbling because I'm revising. I'm trying to think about all the stuff I was learning. So we have eons, which is thousands of millions of years ago. Uh, so several hundred millions years ago. So we know there are four eons: Hadean, Archean, Proterozoic, uh, Proterozoic, and there is one more. I don't know why it's not written, but Phaneroic, Merozoic, Phanerozoic. Then comes eras. Here there are several hundred years. This is several thousand years. This is several hundred years. Eras is 700 years. So we have the Hadean era. So in Hadean area, we had the Precambrian stage. Here only you will see formation of atmosphere, lithosphere, the hydrosphere, then unicellular bacteria, formation of blue-green algae, stuff like that, and formation of first small-bodied arthropods, which were in water mostly. Then your comes next era, which is Paleozoic era. So Paleozoic era has periods. Period is tens of millions of years, hundreds of millions of years, not several. Tens of millions of years. That's the way. Several tens of millions of years. So we have the Cambrian era. So marine invertebrate. Then Ordovician era. There only first fish came. Ordovician era. Then came Silurian era. Here we had the first traces of land plants, terrestrial plants. Then Devonian era, the amphibians. Oh, what was the first amphibian? फर्स्ट फिश का नाम याद रखना है. I am just double checking. In Pica species or Ordovician era, and first amphibian. And after that, Elignar, Elginr. I'm sure this was first amphibian. Exactly, this is the first amphibian. How to spell it? Elegant. This is how to spell it. Engine. So instead of in, Elgin. Elgin. Think about it as a Mexican, and Peton. So this was. Uh, let me see. Really good. This was one of the first amphibians, and Pikia species. The first which was Is the earliest known is this. We know it was from the Pikia species. This is believed to be the earliest fish that is known. Haikukaitis. Then that was five. Uh, First amphibian came in Devonian period. Silurian first. Silurian first. This came. Uh, you had Silurian first land animal came. Then Carboniferous era. This is when reptiles started to come. First reptile का नाम याद रखना है. It was Ignodon first. Sorry, Hylonomus. Oh, it was new. Hylonomus. Sorry, Hylonomus was the first reptile. Yes, Hylonomus, and which came about 360 million years ago. Then we have Permian era. This is when reptiles started to dominate and amphibians started to getting replaced. Then came Triassic area, frogs and turtles. So this is when reptiles started to differentiate, right? Reptiles and amphibians started to differentiate. Then you had Jurassic era. Jurassic, maybe obviously know age of dinosaurs. Then came Cretaceous, extinction of dinosaurs. Woohoo! That was 144 million years ago, which is quite recent. 144 years to 65 years ago. Then comes the next period, tertiary period. Oh, by the way, Paleozoic era में आता है your first amphibians first age. So Paleozoic era, uh, Paleozoic era. Okay. So remember, Paleozoic era. That is from 245 million years to 570 million years ago. So 245 to 570 million years ago, you have five periods over there. Cambrian, uh, Cambrian. This is when all uh, all modern vertebrates were present and stuff. Invertebrates were present during Cambrian period. Then came your Ordovician period, first fish. Then came your Silurian period, first terrestrial plants. Third came Devonian period, first amphibian. Uh, then came your Carboniferous period, first reptile. Then came Permian, uh, Permian era period, which was your first time when reptiles started to dominate amphibians. Then came your Mesozoic era. Mesozoic era had uh, Mesozoic era had has three periods: Triassic, Jurassic, and Cretaceous. Then came the Tertiary era. Okay, Cretaceous ending is 65 million years ago, end of dinosaurs. Then came the Cainozoic era. Cainozoic era is from 65 million years ago to the present time. We are in right now Cainozoic era. Cainozoic era is the period is called Tertiary. A period in Tertiary had epochs, whatever you want. The epochs are tens of millions of years. Period group, time groups there. So you had the rats and mice as the first mammals, one of the few first mammals. Then came the rabbits and hares, anthropoid apes, and then apes, flowering plants and trees, flowering plants, angiosperms, okay, angiosperms, apes, then early humans, which was in Pliocene epoch, that is 2 to 5 million years ago. Then comes Pleistocene is the quaternary period of the existing era, Calozoic. Now we are in epoch Holocene. Okay. Uh, so we had Homo sapiens, 2 million years to 10,000, 10,000 years, and we right now modern man can be said our history started from 10,000 to 0, 10,000 0. Modern man, Holocene means civilizations, formation of civilizations. Okay, now we go to geomorphology. The main part we go. So direct sources is mining, drilling. Indirect sources is the measure of pressure, analysis of properties of matter. So it has uh, Earth is divided into uh, so we are first studying about lithosphere basically. So interior of Earth. Yeah, let's talk about lithosphere exactly. And you know why is it called sphere now, right? Because there was a core. How the formation of Earth took place. It took place in densities of sphere. We can say it took place like this, and like this. That's what is called lithosphere. So we have uh, core. Then comes core, uh, which has a solid core. Then comes the liquid core, which is the outer core, right? Then comes the mantle. Mantle also has three parts, by the way. uh, then comes oh shit, formation lithosphere, my bad. Then comes your uppermost solid mantle, crust of the earth, that forms lithosphere. This is mantle. Mantle has uppermost solid, less solid, middle solid, stuff like that. So crust is the outermost solid part of the earth, brittle in nature. Thickness is 5 kilometers. Thickness is 5 kilometers. Oceanic thickness. So oceanic, we take off crust. Okay, so crust has 5 kilometers ocean and 30 kilometers continental. That's why we have oil drills, by the way. Mean density तो नहीं याद रखना है, 2.7 grams. Made of silica and aluminium. Ocean crust is made up of heavier rocks. Uh, uh, it is magnesium and silica predominantly. Then comes mantle. So, so mantle has a little bit of discontinuity. It is solid state. It has the density higher than crust portion, made of so mantle is made up of mafic, that is magnesium bearing mafic silicate material, so magnesium bearing, ferrous bearing, that's ferric, iron bearing, and iron bearing. So basically iron magnesium, ferric, and iron bearing silicate minerals, so mafic. Asthenosphere is the upper portion of mantle. Yes, asthenosphere. Uh, the word astheno means weak. It is extending up to 400 kilometers and has a density uh, higher than crust. It is the chief source of magma and way to the surface during that's mantle. Volcanic eruptions happens in mantle. The upper to lower mantle is separated by layer known as Repti continuity. This is Repti discontinuity. I don't know. Can you see this? Yeah. So this is mantle and upper mantle. So this is Repti discontinuity. Mantle has kitna mafic silicates. Then we have it is 2,900 kilometers in depth, and depth. So if we are making a proper right, so this is crust, right? This is upper mantle. This is called as moho variant moho rovoic discontinuity. ठीक है. So crust, upper mantle, then comes your repti. Sorry, this is repti discontinuity. This is your main. I will just put this mantle this much. This mantle gives rise to your volcanic eruption. Then comes the Gutenberg discontinuity. This is your outer core, which you know is liquid in nature. This is the inner core, and this is called as Lehman discontinuity. uh, oh no. Oh shit. Oh fuck, yeah. Fuck. It is from 30 kilometers. Oh, it's 5. Lana, south part of Pangaea, which broke off. Wagner ने concept हाँ. Coastlines of South America and Africa shapes over. This is something that you will notice. I will better show you this. It again started to take a wrong way, right? So I will show you a better way by this. So we know that ki South America. The reason why he said is ki South America's uh, eastern border towards the ocean coastlines, eastern coastline, and the west coastline of Africa continent is, which is separated by Atlantic Ocean. By the way, remember Atlantic Ocean is always S, and Pacific, Australia, Indian Ocean. Indian Ocean is just here. Indian Ocean, Southern Ocean is below, Arctic Ocean is above. India is only connected to one ocean. Bay of Bengal is here. Arabian Sea is here. Here comes Europe. North Sea is here. Oh my god, this is mid-Silurian. Acha, this is when terrestrial plants came. This is late Permian. This is when Pangea was present. So this is our Paleotheteus Ocean. Not only they were amorously Triassic. That's Middle Eocene. That's very new. Okay, how should I show? Because I want to show Laurasia and Gondwana land. And you can see India, Antarctica, South Australia, okay, Africa. Okay, so Gondwana land got cut like this, and this went the Gondwana land went sideways like this. Not sideways. It just went. If you follow my cursor, it went like this towards the Tethys Ocean. Okay, North China, South China got attached to here, India. When this got attached to here, we have Russia here, Siberia, Europe. That's how. That's what the continental theory talks about. Oh, oh, I am talking to myself. I am talking to myself. There's no one obviously. Evidences for Wagner is obviously the shapes of the continents. Here we talk about the South American west east coastline and African west coastline, how they differ. Then we have fossil evidences. We have reptiles like Mesosaurus, which is found in South Africa and also in this South America. Then we have rocks of the same ages, which can be found in. Uh, it is best to take the example of South America and South Africa and South America because we know Gondwana landed broke off, and it is the most evident example. Then placer deposits in the Ghana coast and Brazilian plateau are similar, and the paleoclimatic evidences that the sedimentary rocks found in glacier deposits and Gondwana system of sediments from India is this is see fossil remains then this is the fossils. Then this is fossil of evidences of Liosphere Lithosaurus, which was found in Africa, India, and Antarctica. Still, how many hours now? See, this is earthquake, shaking of earth in simple minds, but actually, मैं is actually the elastic equilibrium of rocks which gets disturbed, and which usually happens in crust lines, which usually happens in crust lines. One of the biggest crust line is uh, South San Francisco crust is the major faults, right? The major faults in Earth. Actually, I should remember this. Why am I not remembering that? So, San Andreas Fault. Sorry, San Andreas Fault, East Anatolian Fault, Chile Subduction Megatrust, Banda Detachment Fault. Right. So, major tectonic plates are Antarctica and surrounding oceanic plates, uh, which oceanic plate meaning uh, the plate around the Southern Ocean includes the North American plate as its whole. Oh yeah, this is the best way. So this is South American plate. This is North American plate. which also has Eurasia, the Eurasian plate, African plate, Eurasian plate, Indo-Australian plate. This is Pacific plate, right? Then you have minor plates such as Nazca, Cocos, Philippines, Fuji, Caribbean, Juan de Fuca, and this. Plate tectonic theory is disproved, right? But it is used for earthquakes. It only talks about how tectonic plates move. It is not how continents were formed. Um, Plate boundaries, mountains, trenches, how they are formed, made oceanic ridges, volcanism, earthquakes are direct consequences of interactions between different plates. Then divergent plate boundaries is which leads to formation of ridges, oceanic ridges and stuff like that. So mid-Atlantic ridge. So I will quickly go to this part. So I want which that shows ridges as well. Oh my god. Oh, this is actually very good. This should ridge. See how plates will form. No. Yeah. Yeah. This is a bit. This is called as a convection theory. Convection current theory. So convection theory is convection currents going towards top, right? Pulls, uh, which pulls crust into. So this is how potentially plates were formed. Oh, we go to sleep. I am kind of so streaming now. Is whatever. Oh, sure, let's complete this. Started for like 4 hours now, 3 hours now. We rest for a bit. I actually was revising geography, Indian geography before this. Yeah. Thank you guys. Thank you, Ghost. Oh, Ghost.